There is a number that almost no one knows, and it is one of the strangest facts in all of physics. The atoms that made up the person you lost are still here. Not their memory, not their echo. The actual atoms. Carbon, oxygen, nitrogen, calcium. The same particles that form their hands, their voice, the specific curve of the face you can still see when you close your eyes. Physics is very clear on this point. Not a single one of those atoms has been destroyed. They have only changed address. And the man who understood this better than almost anyone who has ever lived spent the last decades of his life carrying a letter he wrote to a woman who no longer had an address at all. His name was Richard Feynman. He won the Nobel Prize for describing how particles behave at the smallest scale of reality. And the strange thing, the thing that this entire video is about, is that the same physics he spent his life describing has something to say about the question you have probably asked in the dark more than once. Where did they actually go? It has an answer, and the answer is stranger than either comfort or grief prepared you for. Let us be precise from the beginning, because precision is the only honest thing to offer here. Quantum mechanics is the most tested theory in the history of science. Its predictions have been confirmed to 11 decimal places. It runs the transistor in the device you are watching this on. It is not mysticism, and it is not a metaphor for the afterlife. Nothing in this video will tell you that physics proves consciousness survives death, because it does not, and anyone who tells you otherwise is selling something. But there is a real question underneath the grief, a physical question about matter and energy and information, and physics answers that question with unusual clarity. So we are going to hold two things at once: what the mathematics actually says, which is verified, and what it might mean, which is where you and I are allowed to stand and wonder. Keeping those two apart is the entire discipline. Feynman himself was ferocious about it. He once said that the first principle is that you must not fool yourself, and you are the easiest person to fool, so we will try not to. Begin with the atoms, because that part is not theoretical at all. It is chemistry, and it is measured. The average human body contains around 7 octillion atoms. That is a 7 followed by 27 zeros. When a person dies, those atoms are not annihilated. The law of conservation of mass and energy, one of the most solid results in all of science, says that matter is never created and never destroyed in ordinary processes. It only transforms. The carbon that was in their bloodstream returns to the carbon cycle. It becomes soil, then plant, then air. The nitrogen rejoins the atmosphere you are breathing right now. Statistically, and this is not sentiment but calculation, you have almost certainly already inhaled atoms that once belonged to every human being who lived more than a century ago. The particles do not disappear. They redistribute. So at the level of pure matter, the honest scientific statement is this: the person is gone, the atoms are not. Gone from reach and gone from existence are not the same thing. That distinction is going to matter more and more as we go deeper. Now we descend past the atoms into the layer Feynman spent his life mapping. And this is where the concepts get strange. The first one is called superposition. In quantum mechanics, before a particle is measured, it does not have a single definite state. It exists in a combination of possible states at once. This is not a trick of language, and it is not our ignorance about the particle. Experiments have confirmed it thousands of times. The particle genuinely occupies multiple possibilities simultaneously until something interacts with it. The most famous illustration is a thought experiment by the physicist Erwin Schrödinger, who imagined a cat in a sealed box whose life depended on a single quantum event. Until the box is opened, the mathematics describes the cat as both alive and not alive at the same time. Schrödinger actually invented this to show how absurd the idea felt. But the absurdity turned out to be real at the quantum scale. And here is where grief recognizes something in the physics. Because there is a state you know very well, a state you live inside every day, in which the person you lost is both gone and not gone. You reach for the phone to call them, and for half a second, they are alive. You set 2 cups down out of habit. Some part of your nervous system has not yet collapsed the wave. This is not a poetic comparison to a physical fact. It is your brain doing something the physics describes literally. Your memory holds them in superposition, present and absent at the same time, until reality interacts with you again, and the state collapses. And it hurts every single time, because the collapse is a measurement, and the measurement returns the same answer. This connects directly to the second concept, and it is the one that surprised even the physicists who discovered it. It is called the observer effect. In the quantum world, the act of measuring a system changes the system. Reality at that scale is not a fixed thing sitting there waiting to be seen. It is something that resolves in the act of observation. The most rigorous demonstration is the double-slit experiment, run in laboratories for over a century, most precisely by physicists using single photons at institutions including the Hitachi Research Group in the 1980s. When no one measures which path a particle takes, it behaves like a spread-out wave of possibility. The moment you measure it, it becomes a single definite point. Observation does not just reveal reality. At that scale, it participates in shaping it. And this is the mechanism, the actual neurological mechanism, behind something you have felt. The person you lost exists now, in the only place they can still exist, inside observation, inside memory. And memory is not a recording. This is confirmed neuroscience established by researchers including Dr. Karim Nader, and later work published in the journal Nature. Every time you remember someone, you do not play back a stored file. You rebuild the memory, and in rebuilding it, you change it, and then you store the changed version. The technical name is reconsolidation. It means the person you remember is being shaped by the act of your remembering them. Right now, exactly the way the particle is shaped by the act of measurement. You are not a passive witness to who they were, you are the observer who keeps them resolved. When you stop, the wave spreads back out. This is why people say they are terrified of forgetting a face. It is not sentiment. It is the observer understanding correctly that they are holding the measurement in place. I want to stop here for a moment, because everything we have looked at so far, the atoms, the superposition, the observer, all points toward one idea that most people find hardest to accept. And I have spent months putting together a companion to this channel, called What Feynman Knew About Grief, which follows exactly this thread, the place where the physics and the loss meet. The link is in the pinned comment below. Stay with me, because the concept we reach next is the one that changed how I understand the word distance. That concept is entanglement. Feynman called the phenomena of quantum mechanics the only real mystery, and entanglement is the deepest part of that mystery. When two particles interact and become entangled, they remain connected in a way that has nothing to do with space. You can separate them by a room, by a country, by the width of a galaxy, and measuring one instantly determines the state of the other. Einstein hated this so much he called it spooky action at a distance and spent years trying to prove it was an illusion. He was wrong. Experiments, most famously by Alain Aspect in 1982, and confirmed with airtight rigour by the 2015 loophole-free test in the Netherlands, proved entanglement is real. The connection is genuine. And here is the precise, careful thing to say, because this is exactly the place where people fool themselves. Two human beings are not literally quantum entangled particles. That is not what the physics claims, and I will not claim it for you. But the structure of the idea is not nothing. Entanglement tells us that the deepest layer of reality does not treat distance the way our intuition does. That two things which once interacted are described forever as a single system, no matter how far apart they are moved. You loved someone for 40 years. Your nervous system synchronized studies out of the University of California, using measurements of heart rate and breathing in long-married couples, have documented that two bodies in a long bond begin to regulate each other physiologically. You became, in a real and measurable sense, one system. Death moved them beyond distance. It did not, as far as the mathematics of a bonded system is concerned, cleanly separate the two states. That is why the phantom persists. That is why you still feel them in the room. The system was described as one, and one system does not become two simply because you can no longer see one half of it. Now the fourth concept, and this one explains the physical sensation of grief itself. It is called quantum tunneling. In classical physics, if a particle does not have enough energy to get over a barrier, it stops at the barrier. Full stop. But in quantum mechanics, a particle can appear on the other side of a wall it should not have been able to cross. It does not go over, it does not go through in the ordinary sense. It simply has a probability of being on the far side, and sometimes it is. This is not theoretical. Tunneling is why the sun shines. The fusion in the core of every star depends on protons tunneling through a barrier they classically cannot cross. Your body is alive because of it. And grief tunnels the same way. You build the wall, you get through the workday, you are fine, you are managing, the barrier is holding, and then a song, a smell, a particular quality of afternoon light comes through the wall, as if it were not there. Neurologically, this is the olfactory and auditory pathways bypassing the slow, rational cortex and striking the amygdala directly, a mechanism documented in trauma research for decades. The grief did not go over your defences. It appeared on the other side of them. That is why you cannot brace for it. Barriers do not work against something that does not respect the barrier. Which brings us to the fifth idea, and it is the one that finally makes sense of why this never fully resolves. It is called the uncertainty principle, formulated by Werner Heisenberg in 1927, one of the bedrock results of physics. It says there are pairs of things about a particle you can never know at the same time with perfect precision. The more exactly you know a particle's position, the less you can know its momentum. This is not a limit of our instruments. It is built into the fabric of reality. There is a fundamental fuzziness at the bottom of everything, a place where certainty is simply not available. Not because we are not clever enough, but because the universe does not store the information. And there is a question about the person you lost that lives in exactly that place. The moment of letting go. When, precisely, did they stop being present? When did the state finally collapse? You keep trying to locate it, to fix the position and the momentum of your own grief at once, to know exactly how much you have released and exactly where they are now. And you cannot, and the reason you cannot is not weakness. It is the same reason the particle cannot be pinned. Some pairs of truths cannot both be held with precision at the same time. How much they mattered and how you are supposed to live without them. Both true. Neither fully measurable at once. So we arrive at the question the whole video has been walking toward, and now we can answer it with the physics laid out. Where did they actually go? The atoms scattered and rejoined the world and are, statistically, in the air of the room you're sitting in. The energy that ran their body did not vanish because energy is conserved, it only changed form. The information that was them, the pattern, the specific arrangement, is the harder question. And here is where honesty must stay louder than comfort. Physics has a live and unresolved debate, the black hole information paradox, about whether information can ever be truly destroyed. Stephen Hawking argued for years that it could be, and then remarkably conceded that it probably cannot. The current mainstream view among physicists is that information is conserved, that the universe does not truly erase, only scrambles beyond any hope of reassembly. Now hold that carefully. This does not mean the person survives. It does not mean consciousness continues. I'm not going to tell you that because the physics does not tell me that. But the pattern, the information that they existed, that they were arranged exactly the way they were arranged, that they said the things they said in the order they said them, appears, by the deepest laws we have, to be a thing the universe cannot fully delete. It is redistributed past all recovery, but subtracted from existence entirely. The mathematics is not sure it even can be. This is where Feynman comes back, because he stood at exactly this intersection of the physics and the loss, and he did something about it. In June of 1945, while he was at Los Alamos building the atomic bomb, his wife Arlene died of tuberculosis. He had married her knowing she was dying. He arrived at the hospital too late. He was a man who understood better than almost anyone alive that her atoms were conserved, that her energy was conserved, that at the level of physics nothing about her had been destroyed, only transformed. And it did not spare him a single degree of the grief. 16 months later, this man, this relentless enemy of self-deception, this scientist who said you must not fool yourself, sat down and wrote his dead wife a letter. He told her he loved her. He told her he wanted to comfort and take care of her. He wrote, "I find it hard to understand in my mind what it means to love you. After you are dead, but I still want to comfort and take care of you, and I want you to love me and care for me." And then at the very bottom, he added a postscript that has undone physicists for 40 years. He wrote, "Please excuse my not mailing this, but I don't know your new address." He never sent it. He kept it for the rest of his life. It was found in his files 43 years later, only after his own death in 1988. Understand what that letter is. It is a superposition. It is written by a man who knew, with the full authority of a Nobel Prize, that there was no one to receive it. And who wrote it anyway? Because at the level where you and I actually live, the person is not gone, the wave has not collapsed, the address exists, we simply do not know it. He held both states at once, the physicist who knew, and the husband who wrote, and he did not resolve the contradiction, because it was not a contradiction to be solved. It was the true shape of the thing. Feynman said famously that if you think you understand quantum mechanics, you do not understand quantum mechanics. He meant that the honest response to the deepest layer of reality is not certainty. It is a kind of standing amazement in front of something genuinely strange. And I think that is the only true thing anyone can say about where they went. If you think you understand grief, you do not understand grief. It is not a problem with a solution. It is superposition, an entanglement, and an observer holding a state in place, and a wall that does not stop the thing tunneling through it, and a certainty that the universe declines to provide. The atoms are here. The energy is conserved. The information, the deepest laws suggest, is not truly gone, only scattered past, all reassembling. And there is a letter still, in a drawer, addressed to someone whose new address the writer never learned. He wrote it knowing all the physics. The physics did not stop him. He wrote the letter anyway. That, in the end, is the most exact thing physics has to say. Not that they are with you, not that they are watching. Only this, measured and conserved and stubbornly refusing to be subtracted. Nothing here truly disappears. It only changes into a form we have not yet learned to read.